Hello, this is Mr. Wynn, and this video is over trigonometry part 2. We will be solving for missing sides, and this will require a calculator set in degrees mode. So first, if you're using a TI-84 graph calculator, make sure you're in mode degrees. So in the calculator, you're going to press mode, this button red right here. Then on the third row, you're going to have radian and degrees. Make sure you click degrees. All graph calculators by default do radians. Radians are a different way to measure angles, and we don't use those in geometry. If you're in mode degrees, you're going to get specific answers. For example, the tangent of 45 degrees is 1. If you're in radians, you get a different answer. This is read as the tangent of 45 radians, which is not 45 degrees, which gives you 1.0 or 61, blah, blah. All right, another one. Cosine of 60 degrees is always going to be 0.5. But if you do the cosine of 60 radians, you get this negative number. All right. So you're going to get all these numbers. You're not going to know them. You're going to need a calculator if on the approximation, or you just leave it alone as the exact answer, and I'll explain that in a bit. If you don't have a TI-84 graph calculator, you can use a calculator online. Just Google search Google Calculator. At the very top, you'll see one of these two things. Make sure, again, you're in mode degrees. That's in the top left corner. So here, notice that this is darkened because I'm in degrees mode. For the other one, I'm in radians, so that's darkened. But the cosine of 60 degrees is 0.5, which is correct. The cosine of 60 radians is that negative number from before. All right, again, make sure you're in degrees. All right, so trigonometry is a study of the relation between the sides and angles of a triangle. And again, I told you there's actually a mathematical relationship. The relationship comes from the fact that all similar triangles have congruent angles and proportional sides. Let's take a look at the following 45, 45, 90, and 36, 90 right triangles. So for these left two, what is the tangent of 45 for both triangles? Let's try it. So you pick 45, that's our reference angle. We label HAO, HAO. So the tangent over 45 degrees is O over A. O divided by A, that's 5 divided by 5. That's 1. Let's try the other one. If I do tangent, let's pick this angle here. This is also 45 degrees. I'll label HAO. Here's HAO. Tangent of 45 degrees for the second triangle is O over A. That's 12 over 12. That's also equal to 1. So tangent of 45 degrees is always 1. If I go back to this slide, right here, tangent of 45 degrees is supposed to be 1. So that's true. Let's try a cosine of 60 degrees for both these 36, 90 triangles. So we are at the 60 degree angle. I label HAO. The cosine of 60, remember cosine is ca, A over H. So A is 4 over H is 8. 4 over 8 reduces to 1/2. Let's try the second triangle, 60 degrees. Label HAO, here's H, here's A, here's O. Cosine is 60, and that's ca, A over H, so that's going to be A is 7 over H is 14. That also reduces to 1/2. And then if I go back right here, in this one, cosine of 60 is always going to be 0.5, which is 1/2. So the second video will focus on using this relationship of angles and similar triangles to find all missing sides of a right triangle when you know one non-right angle and one side. All right, so this is more powerful than Pythagorean theorem because you don't need two sides to find out. You just need one side and one non-right angle. Here are the steps. First step, you're going to label HAO from the reference angle. Then you're going to select a trig ratio from SOHCAHTOA where only one value is missing. You can't solve for two unknowns at the same time, only one. So you're going to have to use the angle they gave you and the side they gave you and then one missing side. Then you're going to solve that equation for the missing value. If you want to give an exact answer, leave your answer with the trig function and angle. If given an approximation, type that answer in the calculator and see what you get. So here's a problem. It says solve for x. So we have a right triangle, so we're allowed to use trig. We have one angle that's not the right angle, so 32 degrees, so I'll star that. That's our reference angle. I'm going to label H, A, and O. Notice I have H. So I have to use one of the formulas, trig ratios, that has H in there. So either SO, CA, but I can't do TOA because TOA doesn't have H. So let me write that. So we have SO, CA, and TOA. So we have to use H, so we have to use one of these two. And I'm looking for O, so actually I'm looking for this one. I'm going to use SO, I'm going to use sine. So it'll be sine of 32 degrees equals the fraction O over H. All right, now we solve for x. This is a fraction, so we're going to multiply both sides by the denominator. So on the left side, 25 times sine 32. Well, we don't know what sine 32 is. I don't even know what that is. That's some decimal that goes on forever. So this is going to be 25 times sine 32, so just 25 sine 32. On the right side, these 25 cancel as x. This is the exact answer. Now, if you want the approximation, you type in the calculator. That's what it is on the right, top right. If I type in 25 sine 32 in the calculator, I get 13.2479816. Keeps going forever. Now, most time on a test, on your final exam, for example, they usually say round to the nearest tenths or hundredths. So then you say 13.2 or 13.25. So I'll say this x is about, if you want that number, let's do a hundredths place, 13.25. All right, so now that I know this number right here, 13.25, I can actually do Pythagorean theorem. This is A, this missing number is B, this is C, and you get the last side. But you don't have to do Pythagorean theorem to find that last number. You could also do more trig. So let's try another one. Here's the same triangle, look, but instead of finding x on the left, I'm finding y on the bottom. So this is the other way of finding y, the bottom number, without doing Pythagorean theorem. So we start our angle, reference angle, 32 degrees. Label HAO, here's H, here's A, here's O. We don't know O is, so I can just skip this really. So we're trying to figure out which one uses A and H. So we have SO, Ka, and TOA. So the only one that has A and H in it is Ka. We're going to use cosine. We don't have O, so we can't do this, and we can't and we can't do O because we can't do TOA. So we're going to do cosine of our angle, 32 degrees, equals A over H, y over 25. All right, remember cosine 32 is some decimal that I don't know, and you shouldn't know it. So leave it alone. That's the exact term, exact form. That's like leaving it as a radical or like fraction. But it's not fractionable though, it's irrational. Anyways, this would turn into 25 times cosine 32, which again, just leave it alone like that, equals y, because these 25's cross out. This is the exact answer. So if they want the exact answer, leave it like that. But if they want the decimal approximation, you gotta type in your calculator and see what it says. So in the calculator, I type 25 cosine 32. Again, I'm making sure the mode degrees. And it says it's about 21.20, blah, blah, blah. So they tell you to round to the nearest hundredths, do two decimal places. So we can say y is approximately about 21.20. And you don't put 0. That's the other way of writing that. So we found this, 21.2. So if I do Pythagorean theorem, that left side, that missing side, will actually become that 13.25. All right, one other thing I should mention is this. We do not have to use that 32-degree angle. If you wanted to, you could actually use this other angle up here. That's 58. Remember, triangle sum, all three angles add to 180. If one side's 90, the other two have to add up to 90. And if you start this angle, HAO change, or H has A and O change, and then you could use the other one. I could use sine to find that. And I'll do that for a different problem. All right, let's try the next one. Solve for x. All right, so I'm going to use this angle down here. Here's my reference angle. I have a non-right angle and a right triangle. HAO. Hypotenuse is missing. Adjacent we have. Opposite is missing, where that's x. That's what we're trying to find. We're not looking for the hypotenuse, so ignore that. Which of the three uses only A and O, or O and A? So has H and O, which we don't want. Ka has H and O, which we don't want. TOA has both O and A and no H. That's perfect. We are going to use TOA, tangent. Tangent of our angle, 48 degrees, equals the fraction O divided by A. Again, tangent 48 is some decimal that goes on forever that we don't know. Just leave it alone, leave it as is. Solve for x by multiplying both sides by a denominator. 18.4, 18.4. On the left, 18.4 times tangent of 48 is just 18.4 tan of 48. On the right side, the 18.4 cancels out, it's x. That is the exact form. If you want the approximation, type in the calculator. 18.4 times tangent of 48 in degrees mode gets you the approximation 20.44 if you're rounding to the nearest hundredths. So I'll say x is about approximately 20.44. All right, one more problem. Solve for x, y. So say you find two things at once. Again, you only find one at a time. So like before, you start your angle, your reference angle. Label HAO from that angle. That's hypotenuse. This is adjacent next to the star. Here's the opposite side. we have to use A because we have 13. Then we have to find either O first or H first. It doesn't matter the order. So I'll try to find X first or H. So if I'm trying to use 13 this, I'm going to use which one has A and H in it. So out of SO, Ka, and Toa, only one of them has both A and H, and that is cosine, Ka. So I'll do that first. So the cosine of our angle, 22 degrees, equals O, which is Y, sorry, not O, equals A, 13 over H, X. All right, again, leave cosine 22 alone. We're going to multiply both sides by denominator to get rid of it. I'm going to do it like this. I'll multiply both sides by X this way. So this is going to be X times cosine of 22 equals 13. And you technically should put a parenthesis on here, but you don't have to. Then to get X by itself, you divide both sides by cosine 22. So X will equal 13 over cosine of 22. That's the exact answer. If you go into approximation, here it is. X is approximately 14.02. All right, now let's find Y. Now actually change things up. I don't want to use 22 degrees. I want to use this bottom angle down here, which is going to change my HAO. So if I do triangle sum, this is going to be a 68 degree angle. Let's use this, and it works perfectly fine. We're going to label HAO. Now technically we know H is about 14.02, which you could do it, but you shouldn't use an answer that you just found recently that's rounded. That's bad, unless you use the exact number. So I'm going to avoid using H. I'm going to use O and A. The one that has O and A is TOA, tangent. So I'll do that. So tangent of 68 degrees equals the fraction O, which is 13, over A, which is Y. I'll multiply both sides by the denominator, Y, to get Y tan 68 equals 13. Then divide both sides by tan 68. So Y equals 13 divided by tan 68. That's the exact answer because we don't know what tangent 68 is. It goes on forever. If you go in the approximation, type in the calculator, 13 divided by tan 68 is about 5.25 if you round to the nearest hundredths place. All right, if you check that, that does make a right triangle, 5.25, and 13 has legs, and 14.02. All right, that's for the video. Make sure you ask questions, and join live sessions, or watch the recordings. Thanks for watching. See you soon. Bye.